Hey everyone, today I'll be going over a Leetcode problem, 1807, evaluate the bracket pairs of a string. So they have all this junk here, but it's actually really simple, right? And I'll explain why it is. So let's get all these test cases here, like so. So we're given some string and we're given some knowledge. And all it means is, so they have like a huge description, but really all we have to do is we give some key and value pairs. So name maps to Bob, age maps to 2, and we have to swap the keys with the knowledge. So name becomes Bob, because we have that in our knowledge, and then age becomes 2. And the string becomes that. And if you actually look, this is what we're supposed to have here. Very, very simple. The only caveat is if the key doesn't exist. So given this test case here, and you're probably already thinking how we can do this. Given this test case here, we don't have a name key. So it evaluate to a question mark. So S now becomes high with question mark. And you look, and that's actually the answer for this example here. So yeah, very, very simple. All we have to do is just go through the knowledge, create a hash map out of it. Whenever we see a parentheses, if the parentheses closes, check if we have the key. If we don't, it's a question mark. If we do, then we check what's in our knowledge map, right? So let's actually have our map here, and I'm going to map a string to a string. So we'll go through our knowledge and fill this up, and I'll call this swap, because these are really what they are, is what the swaps are. So let's go through each list, and we'll call this a K in knowledge. And let's just go swap.put k.get0, and let's map it to k.get1. So like such, just mapping them so that we can have O1 lookups using a hash map. You could always look it up in the knowledge array, but that would be ON, so we're using a hash map. Next thing, we'll need 2 string builders, and I'll explain why. So this will be the res, and this will be a new string builder, like such. And then we'll need another one, and I'll call this current key, so the current key that we're on in the string. And I'll explain why we do that. At the end, let's just return res to string, because we know it'll be valid. And then actually what we can do is we can just go through the string, right? So for each character in s.toChar, so just walking through the string, let's actually check if this is an opening parentheses. So if C is equal to the opening parentheses, we know that this is actually the start of a key. And let's actually have a Boolean here that says like is key. And it's false at the beginning, because we're not in a key. If it's an opening parentheses, that means we are now in a key. So is key is going to be set to true. Else if C is a closing parentheses, we won't do anything yet. Else, this means it's not a parentheses and it's not this. So we could either be inside of a key right now or not inside of a key. So basically, if it's not a key, it's just a regular character, and it should just be added to the res as normal. So we can go res.append C just as normal, because this is not a key. Else, that means it is a key, and we actually have to add this to the current key. And that's why I have a string builder for current key as well, because we could basically just keep building out the current key. So we can go current key.append.c. So then now we have everything we need for when it closes, right? Because if it closes, current key should have our current key, and we could just get the swap and then put it into result. So it actually works out quite elegantly, and we'll set is key to false, because that means that it's no longer a key because it's now closed. So what we can actually do is we want to get the swap for this current key, right? So we can actually just go res.append swap.get current key to string, like such. And it actually works out quite well. So let's go ahead and run this. And Bob is no. Oh yeah, so the reason why this is because the key was never reset. So we actually want to go current key is equal to new string builder, because we're done with this current key. And it's actually still going to be wrong. It's going to work for this test case, but we'll see why. And actually, we want to do that after we append this to res. So let's run this. It looks like I'm running too soon. Nice. So once we do this, it looks like it's good, but if we actually use the example test cases, we'll see that it doesn't work for one of them. And that is because this high here, remember we were going over this test case, it didn't find the key, so it said null. We actually want it to be a question mark instead of null. So instead of get, let's do get or default. And if this doesn't exist in our map, let's just have this be a question mark. And we can go ahead and run this again. And it looks like it's pretty good. Let's go ahead and submit it. And yeah, 81%, 96%. I'd say that's pretty good. So let's talk about time and space here. So time is actually just on. And that's because we use the hash map and everything's good. We're really just going through every single character once, right? And we're using a hash map, so we're not doing anything funky. So we're just going on times, where n is the length of the string, right? And then space is actually going to be on as well. Basically where n is, and I could call this OK, where k is knowledge length, because really the only space we're using, well, and we have the res and the current key. So really I could call space on as well, because not only are we building a hash map, but we also have these two string builders here that we're filling up along the way. So time on, space on. Yeah, thank you for watching. Hope this made sense.